All right, welcome to class. The initial precursor to the Pythagorean Theorem, which we're going to be doing soon, is square and square root equations. We've been solving equations all year long, but today we get to look at finally the E in SADMEG or GEMDAS, which is the exponent component, right? So square and square roots equation. We're going to solve an equation that contains squares and square roots. We're going to recall some Unit 1 knowledge on exponent rules and when to apply them and when not to apply them and what they apply to. Remember, exponents are all about that base. Recall the perfect squares. So, warm up. Let's see what you remember from Unit 1 and evaluate some of these square roots here. Pause the video. I'll do the same. See if we come up with the answers. All right, so welcome back. I think you should remember some of these from Unit 1. Square root is not dividing a number by 2, but it's saying what times itself is equivalent to me. When the number got multiplied by itself one time, it equaled me. What is that number is basically what a square root is doing. It is the inverse of a square. So the square root of 256 is 16, because 16 squared is 256. The inverse of that, 15 to the second power, 15 squared is 225. When square rooting a fraction, you square root the top number and square root the bottom number, and conveniently these are both perfect squares. So the square root of 9 is 3, the square root of 81 is 9, and 3 nines can be reduced to 1/3. Square root of 121 on the top is 11, square root of the bottom 25 is 5 11/5. You can leave it just like that or call it 2 1/5. Now, I left these ones blank because these are sort of ones that we did not go into. Square root of x squared. When you undo something that is squared, well, x is being squared. The square and the square root will undo each other, and you're just going to simply get x. Right? And that makes perfect sense. If this x was whatever your favorite number is, I'll just use 5 for all intents and purposes here. And I simplify this expression. 5 squared is 25, and the square root of 25 is still 5. So no matter what value I put in for x, I'm still going to get x out of this expression. So algebraically, squares and square roots undo each other, and that's sort of the theme for today. 5 root 49. 5 root 49. Well, anytime you have a number sitting next to any other expression, hopefully by now in pre-algebra you're realizing that that number is a multiplier. It's a factor. So what I'm going to do is, following GEMDAS, I'll simplify the square root first. So that is a grouping symbol and an exponent. So basically this becomes 5 times the square root of 49 is 7. 5 times 7 is 35. And you might have had some intuition of how to do those last two. I just wanted to make sure I explained them a little deeper. Moving on. Okay, so recalling the definitions, write them down. If you don't remember, a square is an exponent of 2. Also, for intents and purposes today, it is the inverse anytime that you see a square root. A perfect square is a square of a whole number. Okay, aka, or I should probably say the counting numbers. Perfect square is 1, 4, 9, 16, 25, 36, 49, etc., etc. are perfect squares. As you know, all of the numbers in between these are non-perfect squares. If you square root them, you're going to come up with a decimal. We will have to deal with non-perfect squares from time to time. And a square root is simply the inverse of a square, the operation that undoes it. And if you want to draw the little square root symbol in there, that would be appropriate to do. Square root symbol, the checky rooty thingy guy, right? So square equations, when solving an equation using SADMEG, like we have done in every single unit in pre-algebra, getting those solving skills right, you undo a square with a square root on both sides when you get to E for undoing exponents. Let's highlight this. Let's highlight this note. When solving an equation using SADMEG, you undo a square with a square root on both sides when you get to E for undoing exponents. So we have this example. Let's practice this example here. I'm going to put up my little border wall in between the two sides of the equation just for some neatness here. So, and I'm also going to put up SADMEG. on the side of the paper. Okay, so we undo addition and subtraction first, multiplication and division second, exponents after that. So it's basically the third inverse operation step. Then I'll apply that same process to any groups that I've had. So the first step would be I'm going to undo the addition or subtraction. I'm going to undo the subtract 2. And then I'll simplify on both sides. 5x squared is equivalent to 22 minus 2, which is 20. Okay, now I undo any multiplication or division, and I do have a multiplier of 5. How do you undo a multiplier of 5? Well, we're going to divide by 5. Standard procedure. We've done it on almost every single unit this year. Now my equation, here's what it looks like. X squared equals 20 divided by 5. X squared is equal to 4. Now this is where it gets new, right? How do you undo a square? Well, if you refer back to this note that's up top, you undo a square with a square root. So I'm going to square root both sides. Just like in the warm-up, the square root of x squared is going to cancel that square out. The square root of the other side, I'll have to evaluate the square root of 4. So simplify on the left. Square root of x squared is x. The square root of 4 is 2. Now, for future classes, you might have to also apply the negative square root answer as well. So technically, the square root of 4 could be positive 2 or negative 2. But here's the good news. We are in geometry, and we are going to be finding the values of distances. And because distances cannot be negative, we don't have to worry about that right now. All right? So we're just going to go x is equal to 2. We're going to evaluate the positive square roots. When you get into Algebra 1 and Algebra 2 and you're applying things that are not necessarily distances, then you're going to have to be a little more specific about the square root evaluation. Right? So when solving an equation using SADMEG, you undo a square root with a square. So if a inverse of a square is a square root, the inverse of a square root is a square. Hopefully I said that correctly. I think I did. Okay, you undo a square root with a square on both sides when you get to the e for undoing exponents. All right, so let's go ahead and put up a wall, and let's get a square root equation. So this is an ugly looking equation. There's this weird funky thing that's happening to x right now. Let's put up SADMEG on the side of the notes. And I have to undo any addition or subtraction first. I'm going to add 17. Both sides. Then simplify. Cancels out on this side. Now I have to evaluate 23 plus 17, which I believe to be 40. And then I am on to multiplication and division. Do we have some? Yes, there's a number that is sitting next to an expression. That's a multiplier. So I have to undo the multiplier first. I'm going to have to undo the multiplier of 4 by dividing by 4 on both sides. Then my equation says this: the square root of x is 10. And this is where you stop and think. Okay? The square root of what number results in 10? The square root of what number results in 10? Right? Hopefully you have it by now, with just some pre-algebra mental math skills. But you can undo a square root with a square. So if you're unsure, square both sides of the equation. Squares and square roots undo each other. And voila, it cancels out on this side. I have x, and 10 squared is, hopefully you know this by now, 100. Right? And just like any other equation, you can go back and see if it makes sense. Plug it back in. 100 in for x. The square root of 100 is 10 times 4 is 40 minus 17 is 23. Our solution checks out. Moving on. Okay? But what if those thingies are on both sides? So recall, back to Unit 6. When you have the variable expressions on both sides, when you have the variable expressions or the variable terms on both sides, even after you have simplified it, you need to add or subtract the variable using inverse operations until they are on the same side. I'm not sure exactly why my text is all jumbled up there. Let's see if we can fix that. Nope, not fixing that right now. Okay, so we're going to have to add or subtract the variable until they are on the same side. Let's get an example for one of these. Let's put up our divider wall here. All right, so I've got variable expressions on both sides. 8n squared minus 1 is equal to 3n squared plus 44. Subtract 3n squared from both sides. Or you could subtract 8n squared from both sides. Okay. Now it cancels out over here. I'm going to have 5n squared minus 1 results in 44. Okay. Now I've solved the problem that we started off with. Put SADMEG up here, and we're ready to start solving. Okay. Add your 1 to both sides. Undo any addition or subtraction first. 5n squared is equal to 45. Then undo the multiplication with division. 45 divided by 5 is positive 9. Now I'm on to the exponent. What is the inverse of a square? I'm going to have to, hopefully you're picking up on this, square root on both sides. And n is equal to the square root of 9. And the square root of 9 is 3 or negative 3, but we don't have to worry about that for this particular course. Okay, so n is equal to 3. All right, so if those thingies are on both sides, you're still going to have to add or subtract the like terms so that the variable expressions are on both sides. That's the moral of that story. Okay, practice example. Pause the video and try this one on your own. Okay, this one worked out interesting. When you subtracted the 5 from both sides, okay, you ended up with the square root of d is equal to negative 14. And then if you square both sides to undo the square root, you're going to have to square the whole other side, including that negative sign, which is going to make it a positive 196 because, as you know, negative 14 times negative 14 is equal to 196. Now, to plug this one back in, if any of you guys tried to check your solution by plugging it back in, you had to understand that a square root can yield both a positive and a negative answer when plugging it back in. So the positive one will not work, but the negative one does. So that's just a FYI in case you were confused about the plugging it back in. So if I use the square root of 196 as 14, 14 plus 5 is obviously not negative 9. But if I say the square root of 196 is a negative 14, then negative 14 plus 5 does result in negative 9, and I have found the solution. D's answer must be 196. So just a little FYI, that's a little different. Okay, pause the video, try this one on your own. All right, this one was more like the first practice example, and hopefully you got s is equal to 5. You can pause the video and check out my steps if you have any further questions on that. Try this next one on your own. All right, on this one, you had to combine the like terms first. 10c squareds plus 12c squareds is going to be 22c squareds, right? And then anytime that you have two of the same variable term on the same side, you're going to have to know, just like we've done all year, you have to combine your like terms. So follow the rest of the standard solving procedure. Undo the square with the square root, and c was 2 in that one. Okay, I think this might be last one, second to last one. Let's do these last two on your own, and I'll go through them both at once. All right, so in practice example number 4, you had to distribute first, something that we've done all year. We've got a multiplier on the outside of the parentheses, so that becomes 4 times the square root of n is 4 root n. Plus 28 is equal to 12. If some people chose to divide the 4 right away, you would not be wrong to do that either. But standard procedure that we've done all year, we see a multiplier on the outside, we distribute in. So 4 root n plus 28 is 12. Subtract the 28, divide the 4, and the square root of n is negative 4. And you have to make sure that you square both sides so that negative 4 times negative 4 becomes positive 16. On the next one, you had to combine like terms, something else that we've done all year long. So I have no idea what the square root of c is when I started this problem. No clue what the square root of c was. But I did know that I had 3 of this thing plus 5 of this thing, and they're being added together. 3 of this thing plus 5 of this thing. How much of that thing do I have total? 3 plus 5 is 8 root c. I combine my like terms, right? So I have 8 root c is equal to 16. Now I can divide the 8. Now I can undo the square root with a square, just like the moral of today's story is to find my final solution of c being equal to positive 4. Hope this helps. This is the last lesson for some of you before spring break and the first lesson back from spring break. So you can move on to the homework that is in the workbook 8.51. See you next time.